Hi, Terri Bucci from Ohio State University Math Literacy Initiative. Thanks for joining us. If you're joining us live, if you're not joining us live, I'm not talking to you, but anyway, we're going to be posting this on our Facebook page. So this was our first Monday Math Day, and we're really excited to be able to, the people at the Math Literacy Initiative at Ohio State, are really excited to be able to serve our community this way. So if you have questions or comments, or if there are certain things that your students or children are struggling with at home, we know a lot of teachers are working overtime at home with their students and communicating with them in a variety of different ways. So they're overloaded too. So we just want to help where we can. So if you have some questions or ideas or topics that you would like us to focus on for next Monday Math Day, let us know. You can message us at Facebook or on Instagram. So today we had sessions on all of these different ideas. Right now we're going to talk about questioning. And I'm going to leave this 2 o'clock session, I believe, open for more pedagogical questions. Pedagogy is just the fancy word for teaching. So for teaching questions, like if you have some concerns about how you're teaching, or if you wanted to quiz them, what kinds of things would you do, or what kinds of activities, how do we get kids to sit still for a period of time, what period of time is appropriate for each age child, all those kinds of things. Those are all pedagogical or teaching issues. So if you have any questions about any of those, please let us know as well. So we're going to talk about questioning, and you might think that that's kind of a simple thing to talk about, but really questioning is incredibly important for the student or your child, but it's not as simple as you might think. So let's talk about some of the specifics of questioning. So when do we question? We question when we want to know information. So too often, though, in mathematics, we do it just for that, like question to get information. What's 5 plus 5? Or what's the complement of a 35-degree angle? Like that's just like a direct question, just like we just want to know the answer. But when we just want to know the answer, we lose so much valuable information, because the real idea behind questioning in a math class, when you're teaching students, which now all of you are, is really to find out what the child or student is thinking about math. That's really the important piece, because we can question somebody in a way that I call it a guess my answer question, like do you know the capital of Columbus? Sorry, the capital of Ohio. And they'll say this answer and this answer and this answer, and you're really just trying to get them to guess your answer. Hopefully, if you're from Ohio, you know it's Columbus, but it's just like a really rudimentary kind of question, and it's one where you can just see it on students' faces that they know they're not giving you what you want to hear, and so they're just spitballing whatever they want out at you. We don't learn anything about what a student's thinking about with that kind of a question. So instead, we want to have driving our questioning, we want to, the idea of how can I find out what this child is thinking? That's a great question. So if you can ask them, so maybe your child is playing with his or her toys and they separate them out. I know my kids used to do that. And you could say, oh, I see that you did blah, 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 which in that case, you're not asking them anything. You're telling them what you know. Well, when we're teaching, we don't need the teacher to tell us what we know. We already know what we know. We want to know what they know. So the question in this sorting kind of thing, if your child is playing and sorting, is why did you sort them this way? Why did you sort them this way? And then take one of the toys, if they sorted them, and put it in the wrong pile and say, can I put this one here? And so instead, you're asking them, like they're the owners of that knowledge, and you're asking to be invited in to their math negotiation inside of their head. What a cool place to really be able to see and hear, think about how your students thinking about mathematics. So you'll notice that last question I said started with why. So the first real key piece is question by thinking about what question you could ask to find out what your child's thinking about mathematics. The second key point is why. And there's a caveat to this, and that is always ask why. We have a tendency to only ask why when something's wrong, and students learn that really fast. So I don't know if I teach college students, and it's one of the first times I ask them why, they automatically are like, you can just see it on their face, and they want to change their answer, and then they learn that in my class, I really want to know why. Like, I'm going to ask why whether a question is right or wrong mathematically, because the only way I can help this student is to know what they're thinking, and the only way I can know what they're thinking is to ask them why they did something. Now, you have to ask why, and answering a why question is really hard. It's much harder to answer a why question than it is a what question. So when you start asking these why questions, whether it's right or wrong, keep asking why. Then the students have to justify their answer. Well, just getting it clear in their noggin about how they're going to say it to you, regardless of what age they are, how are they going to say it to you so that you can understand what they're thinking? That really stretches where they're thinking, how they're thinking about these ideas. How can I make it simple for my mom or grandmother or grandfather or dads or whatever? How can I think about that so that I can explain it to that person so that they understand how I'm thinking? So I say this because you have to ask why, and then you have to be still. You can't, students will also learn, your children will learn very quickly that if you ask a why question and they just look at you, you're going to become so uncomfortable that you're going to tell them what you think they said or why you think they said it. So you have to be really patient and don't jump in. Don't jump in. Make it almost uncomfortable the first few times. What your child or student will learn then is that you're not going to answer that why question for them. The why question is the biggie. That's how we can use different ideas. That's the why, and that is so important. So it's important for your child or student to not only be responsive to that question when it's asked to them, but to also ask why to other people so that they can find out how other people are thinking about things. This why question is probably one of the biggest ideas in teaching mathematics for understanding. So really be focused on the why, really have the goal of your student telling you what you think, and then just play around with it for a little. Just chat. Talk about how you can create different things with mathematics. Talk about how you put a table together. Talk about a game that they're playing, and why do you think that a strategy is better than another strategy. These why questions can be embedded into your entire day, into your entire life, and we want students, children, to be innovators, and they can only be innovators if they've answered why questions a lot. So this is just, I know it's a simple thing, asking why, but it carries tremendous weight in our understanding. Now let's get to the kind of more pure pedagogical kinds of ideas. So when we talk about questioning and teaching, we use this idea, Bloom's taxonomy, it's called. It's really old. Bloom's taxonomy is old, and you don't, the names of these things aren't really that important. I just want you to understand the idea. And it's been changed along the way, but it's different kind of levels of questions that we can ask our students or our children. So the very bottom, and it doesn't mean that these aren't important questions, but knowledge questions are kind of the most least complex knowledge question. Like a knowledge question is just, you can answer it in one word. There's really like no other answer. It's just that answer. And what you learn from the child if you ask a knowledge question is, do they or do they not know that? But it's not really know it. It's have they memorize it? Can they just spout it off? Do they guess correctly? That's why knowledge level questions are just kind of, you don't want to only ask knowledge level. For example, 3 plus 5 is a knowledge question. 3 plus 5 is 8. That if you're done there, that's a knowledge-based question, very low level. Comprehension is the next one. So comprehension would take this kind of same question, 3 plus 5 is 8, and it brings it more into the do they understand it. So really you're thinking about how can I ask them a question where it tells me that they understand it. So this is where a why question can come in. So why is it? Do they understand that? Now there are a couple answers. Actually, there's multiple answers. So you have 3 and you have 5. And they could put that down, they could just circle it, or they could say smush things together, or they could, any way that they demonstrate to you that they understand. Comprehension is understand that 3 plus 5 is equal to 8. Application is the next level. Application is, can they apply something and then find a solution? So, and you're at home or in a space right now because of these times, you have all kinds of application questions happening around in your house or your apartment or your condo. There's application questions all over the place. So maybe an application question could be, my husband and I went for a walk and we found really pretty stones along the way. I found 5 and my husband Rick found 3. How many stones did we find altogether? So we're still using that idea. I'm stuck with the 5 and 3, but it's a story. It's an application. Now, I know when I say story problem or word problem, a lot of you freak out. We'll talk about that on one of these pedagogical Monday Math Day. But application questions are really the most interesting from a foundational mathematic idea. That's what our life is. It's all about application. So then we get to analysis and then synthesis. Now there's new blooms too, and let me just go the rest of the way up. Evaluation, and then in the new blooms there's create. Now in the new blooms they blend, I believe, these two, but I still think that they're both important. So when analysis and synthesis, it means different things. So when you analyze something, I like to do hand motions with this. So when you analyze something, you have a body of information, and you're reading through it, and you're finding different points out of it, and you're breaking it apart into these different parts. You analyze it. You're breaking it apart into different parts. That's the analysis of it. Which of them are like this, which are like this, which are like this. You can look at different kinds of equations, which are like this, which are like this. So that's the analysis of it. Synthesis is taking all those different parts and clustering them in a different way. So maybe we had a whole bunch of addition problems, and we separated them out into ones that were sums greater than 10 or less than 10, and then we brought them back up together, and we found out that some sums were even and some sums were odd. So we reclustered them according to our analysis. That's just a real rudimentary idea about analysis and synthesis. So taking a body of knowledge, breaking it up, putting it back together in an organized, structured way. So we can do that all up and down in mathematics. Now, evaluation, sometimes people, when you think of evaluation, you've been evaluated at work maybe sometimes, or I feel evaluated all the time when you walk, on your outfit or your hair or whatever. So we feel evaluated, it's kind of like judge, but that's not what this evaluation means. This evaluation means it's a quality indicator. So you're evaluating. So it's using your ideas about, in this case, mathematics, using your ideas about mathematics to see the quality of something. It could be something like 38 plus 19, and let's say I got 56, okay? So a quality or an evaluation question could be, did Terri get this problem right? If not, why? Or if so, show. Like it's asking them to look at something, gauge its relevance and its correctness, its value, and then they give an evaluation of it. That's what this evaluation is. And then create is being able to take mathematical ideas or any ideas. This isn't just for math. I just have a math mind, so I only think about math. But create is just taking things that we know and repurposing them for something else. A really great idea that's happening now is I know some of the hospitals are taking other machines and turning them into ventilators. Well, the folks that are doing that know a whole heck of a lot about ventilators, and they know so much about it that they can create ventilators out of something else. That's like way up there when it comes to questioning. So all of these kinds of questions are valuable, and they are not chronological. That means you don't have to start here and then move up. What you want to do now that you're home with your child or your student, you want to ask a variety of different kind of questions, but always ask why, whether it's right or wrong, and don't break down and say what you think. Ask why and wait for them to respond. So it's been a delight to be able to be with you, some of you for the day, some just for an hour. We'll be posting these on our Facebook page. And again, if you have specific questions, please post them or comment on our Instagram or Facebook or Twitter. And we'd love to be able to respond to your direct needs for you and your students. So have a great week. Send in some comments or suggestions. If you do some of these activities, take pictures and post them on our page, and we'd love to see them. Have a great week. Love to you and yours.